Welcome to Aurelius Explainer. Tonight, settle in. Let your shoulders drop a little away from your ears. Let the weight of the day begin to loosen its grip, finger by finger, until your hands rest easy. There is nowhere you need to be for the next while. Nothing you need to solve, no thought you have to chase down and pin to the ground. You can let them drift past like slow water. We are going somewhere quiet tonight. Somewhere dark and old and still. We are going down very gently into one of the strangest bodies of water on the face of the earth, and we are going to do it slowly, the way you would lower yourself into a cool bath on a warm night, an inch at a time, letting your body get used to it. Picture a sea. Not the bright, restless sea you might imagine from a holiday, all gulls and glare and the smell of salt off the surf. A different kind of sea, a sea that sits between continents, half enclosed, ringed by old coastlines and older histories, fed by some of the great rivers of Europe. From above, in daylight, it looks like any other large stretch of water. Blue when the sky is blue, grey when the sky is grey, waves that catch the light and lose it, boats crossing it, fish moving through the upper water just as you would expect, a surface like a sentence everyone understands. But here is the thing about this particular sea, the thing that has quietly bothered the people who study it for as long as they have been able to lower instruments into it. The surface is a lie, or not a lie exactly. The surface is true, but it is only the thinnest skin of the truth. Because below that bright living top layer, below the fish and the light and the ordinary churn of waves, this sea is dead, not dying, not threatened, dead already, and has been dead for a very, very long time. Go down about 100 meters, maybe 150, depending on where you are and what season it is. And somewhere around there you cross a line. You will not see the line. There is no curtain, no wall, no sudden change in the color of the water that your eye could catch. But something fundamental changes at that depth, something in the very chemistry of the water itself. Above the line, there is oxygen dissolved in the water, the same oxygen that fish breathe through their gills, the same oxygen that lets all the familiar life of the sea exist. Below the line, there is none, none at all, not a little, not a trace that struggles on in the dark, simply none. And it goes down, that oxygen-free water, for a very long way. This sea is deep. At its deepest, it reaches something close to 2,200 meters, more than 2 kilometers straight down into the dark. And its average depth is somewhere around 1,250 meters. So when the oxygen runs out at 150 meters or so, there is still an enormous volume of water beneath that, almost the entire body of the sea that contains no oxygen whatsoever. Roughly 90% of all the water in this sea is water that nothing you would recognize as an animal can survive in. 90%. Let that number settle a moment, the way silt settles in still water. Imagine a glass of water and only the top finger's width of it is alive, and all the rest, almost the whole glass, is a dark, breathless deep where no fish has ever swum and no fish ever could. This is the Black Sea, the largest body of oxygen-free water on the planet. Scientists have a word for it. They call it anoxic, which simply means without oxygen, and from the old word for not, oxic, for oxygen, anoxic, without breath. And the Black Sea is the largest anoxic basin on Earth, the largest place where a body of water has gone in its depths, completely without the oxygen that life as we usually picture it depends on. There is another word they use, a stranger one, and I want to give it to you slowly because it is the key to the whole puzzle. The word is meromictic. It comes from old words meaning partly mixed. A normal lake or sea mixes. Cold water sinks, warm water rises, storms churn the surface and stir the depths, and over time the whole body of water turns over on itself like a slow soup being stirred, so that water from the top eventually finds its way to the bottom, and water from the bottom comes up to meet the air again. That stirring is what keeps the deep water alive. It is how oxygen from the surface, where the air touches the water, gets carried down to the creatures living far below. The whole ocean breathes this way, in slow currents and overturnings, like a great sleeping animal whose breath you cannot see but can trust is there. A miromictic body of water does not do this. A miromictic body of water is partly mixed at the top and never mixed at all below a certain depth. The bottom layer is sealed off, cut away, left to itself. It does not rise to meet the air. The air does not reach down to it. And so, century after century, the oxygen that was once in that deep water gets used up by the things that live there and is never, ever replaced. And the deep goes quiet, and then it goes still. And then, in the end, it goes dead. That is the Black Sea, the largest meromictic sea on Earth and the largest anoxic basin. Two ways of saying the same strange thing. A sea split into two worlds, a living surface, thin as the skin on warm milk, and below it, a vast, dark, breathless deep that has been sealed off from the sky for so long that the human mind struggles a little to hold the number. Because here is the loop I want to open for you, the thread I want you to keep loosely in your hand as we drift down through this. The water at the bottom of the Black Sea, the water down there in the dark at 2,000 meters, has not touched the air in over 1,000 years, some of it longer. Centuries upon centuries it has lain there, undisturbed, unbreathing, unrenewed. When the last of that deep water last felt the wind on its surface, last took a breath of sky into itself, there were no engines anywhere in the world. There were no telescopes. Whole empires that have since risen and crumbled to dust had not yet been imagined. And that same water is still down there now, the very same water, holding the very same darkness, waiting the way it has waited through every single thing that has happened on the surface of the world above it. We will come back to that, I promise we will. We will come back and I will tell you exactly why it has stayed down there so long, why it cannot rise, why the door to the air stays shut, but for now just hold it. Something down there has not touched the air in over 1,000 years. Let that be the small, cool stone in your pocket as we go. Now, this is the part where it gets properly strange, and I want you to know that you do not have to follow every thread. If your eyes are heavy already, if the words are beginning to soften and run together at the edges, that is exactly right. That is exactly what tonight is for. You can let yourself drift down even as we drift down. You do not have to reach the bottom. Almost no one does, and that is part of the point. But for those of you still here, still walking with me along the edge of this thing, consider what it means that nothing lives down there. Because the way scientists came to understand the Black Sea was almost like solving a mystery in reverse. And the mystery has three parts, three questions that the deep dark refuses to answer cleanly even now. Who lives down there? When did it become this way? And why? Why, of all the seas on Earth, did this one go dead in its depths while others kept breathing? Take the first, who or what lives down there in the oxygen-free deep? And the answer, the honest answer, is almost nothing. No fish. There are no fish below the boundary. There cannot be. A fish needs oxygen the way you need it, drawn across its gills from the water, the way you draw it across your lungs from the air. And where there is no oxygen, there can be no fish, no crab, no worm of the kind you would find on any other seafloor, no creature that you would look at and call an animal. The entire deep of the Black Sea, that 90%, that vast, dark majority of an entire sea, is empty of every animal you have ever seen or could name. What does live there is so small you would need a microscope to find it, and so unlike you in the way it makes its living, that it almost belongs to a different world entirely. We will get to them, those strange small residents of the dark in their own time, gently, because they are part of why this sea unsettles the people who study it. But for now it is enough to sit with the largeness of the emptiness. An entire sea kilometers deep, and the only things alive in nearly all of it are invisible. The second question, when did it become this way? And that question, it turns out, opens onto one of the great unresolved arguments in all of marine science, a debate that scientists have been carrying on, politely and not so politely, for decades now, and have still not put to rest. There is a flood at the heart of it, a flood that some believe was sudden and catastrophic, a wall of rising water that drowned a world, and others believe was slow and gentle, a creeping thing that took its time. And the two camps look at the same evidence pulled up from the seafloor, the same layers in the same mud cores, the same shells of the same long-dead creatures, and they read those layers like two people reading the same poem and walking away certain of two different meanings. We will sit with that argument later, near the end, and I will not tell you who is right, because the truth is, no one yet knows who is right. And that uncertainty is one of the most honest and most restful things about this whole story. There is a flood here that science cannot confirm. Hold that one too, loosely, in your other hand. And the third question, why? Why this sea? And that, at least, science can answer. And the answer is so simple and so elegant that once you see it, you will not be able to unsee it. And the whole strangeness of the Black Sea will arrange itself in your mind like furniture sliding quietly into its proper places. The why is the doorway into everything else, and it is where I want to take you now, slowly, with all the time in the world. But first, before we go down, let me ask you something the way I always do, because it makes this dark and lonely place feel a little less lonely. Tell me where in the world you are listening from tonight. Whatever country, whatever city, whatever small room, with whatever lamp throwing, whatever shade of light, on whatever ceiling you are looking at right now, or not looking at, because your eyes may well be closed. Leave it in the comments whenever you wake or whenever you drift back up to the surface of yourself for a moment. I like to read them. It is a strange and lovely thing to think of all of us scattered across the dark side of the turning earth, listening to the same slow voice, going down into the same old water together. And if you are new here, if you have only just found this quiet corner, you might subscribe so the next slow journey finds its way to you on the next night you cannot sleep. That is all. No rush. Settle back. Here is where we are going. We are going to take the Black Sea apart gently, layer by layer, until you understand exactly why it is the way it is. We are going to learn why the deep cannot breathe and what breathes down there instead. We're going to find a river flowing along the bottom of the sea, an actual river, with banks and bends and waterfalls of its own, hidden beneath all that water. And I am not speaking in metaphor, there is a river inside the sea, and you will see exactly how that can be. We are going to find a poison filling the deep, the largest reservoir of a particular toxic gas anywhere on the planet. And then we are going to find the most beautiful and unexpected thing of all, which is that the same poison that kills everything has, over thousands of years, saved something extraordinary, a ship, an ancient ship, perfectly preserved, sitting upright in the dark, its mast still standing after 2,400 years in water that should by every ordinary logic have rotted it to nothing centuries ago. We will get there. We will get to the ship. Stay with me or don't and drift, but the ship is waiting, and it has waited a very long time, so it can wait a little longer for us. Now, the why. Why does this one sea of all the seas in the world go dead in its depths and refuse to breathe? The answer is that the Black Sea is not really one sea at all. It is two. Two seas stacked one on top of the other, two entirely different bodies of water with two entirely different chemistries, and the boundary between them is so sharp and so stubborn that the two have not properly spoken to each other, have not mixed, have not exchanged so much as a proper greeting across the line. In an unfathomably long time, there is a sea on top, and there is a sea below, and they will not mix. To understand why they will not mix, you need to understand a very simple thing about water, the kind of thing you have felt yourself without ever putting it into words. Some water is heavier than other water. Salt water is heavier than fresh water. If you have ever swum in the sea and then swum in a lake or a river, you may have noticed, without quite registering it, that the sea holds you up more easily, that you float a little higher in it. And that is the salt. Dissolve salt into water and the water becomes denser, heavier, weightier for the same volume. And heavy water sinks beneath light water, the same way a stone sinks through air, the same way cream rises through milk because it is lighter, the same way oil floats on vinegar in a glass jar on a kitchen shelf, the heavier liquid settling below and the lighter one resting on top. Two layers that will sit there separated all night if you let them, and never mix unless you shake the jar. The Black Sea is a jar that nobody shakes. On the top sits the light water, the fresh water, the lighter, less salty water. And the reason the top layer is so fresh, so much less salty than an ordinary sea, is one of the loveliest facts in this whole story, because it has to do with rivers, great rivers. Some of the largest rivers in all of Europe pour themselves day and night, year after year, century after century, into the Black Sea. The Danube, which begins in the heart of Europe and winds its long way east across half a continent. The Dnieper, the Dniester. The Don, which empties first into a smaller sea, the Sea of Azov, and then on into the Black Sea through the narrow neck that joins them. And many others besides. Together these rivers drain an astonishing amount of land. The whole catchment, the whole territory whose rain and snowmelt eventually finds its way down through streams and tributaries and into these great rivers and finally out into the Black Sea, covers something like 2 million square kilometers. Roughly a third of the entire continent of Europe drains in the end into this one sea. Think of that for a moment. Slowly, the way you might watch rain run down a window. A third of Europe. Every drop of rain that falls on a vast sweep of fields and forests and mountains and cities, every melting snowflake off a wide range of distant peaks, all of it gathering into rivulets and streams and creeks, and the creeks joining into rivers, and the rivers swelling and slowing and widening as they near the coast, and all of it, all that fresh water from all that land, emptying at last into the Black Sea. It is an enormous, ceaseless flood of fresh water arriving from the top, pouring in across the surface, spreading out as a great fresh lid across the whole sea. And fresh water, remember, is light. So this enormous incoming flood of river water floats. It spreads across the top of the sea and stays there, a buoyant fresh cap, less salty than a true ocean, riding high on the surface because it is too light to sink. If you measured its saltiness, you would find it sitting at around 17 or 18 units on the scale that scientists use, a scale that runs by practical salinity units, which is just a careful way of counting how much salt is dissolved in a given amount of water, 17 or 18. The open ocean, for comparison, sits at around 35. So the surface of the Black Sea is roughly half as salty as the wide ocean, freshened endlessly by a third of Europe's rivers, light and floating and alive. That is the top sea. Now the bottom sea. The bottom sea is salty, properly salty. Saltier than the top, denser than the top, heavier than the top, sitting around 22 units on that same scale. And it got that way because of where it came from, because the Black Sea is not completely sealed off from the wider ocean. It has a door, one door, a single narrow strait that connects it, eventually, to the Mediterranean, and through the Mediterranean to the great world ocean beyond. That strait is the Bosphorus, and it is small. At its narrowest point, the Bosphorus is only about 700 meters wide. 700 meters! You could stand on one bank and see clearly to the other. A great city sits astride it, and through this single slender thread of water, no wider than a long walk, the entire enormous Black Sea connects to the rest of the seas of the earth. Through that strait, salty Mediterranean water makes its way in, and because it is heavier, saltier, denser than the fresh river water riding high above, it sinks. It pours in along the bottom of the strait and slides down into the deep of the Black Sea and settles there in the cold dark below, filling the basin from the bottom up with heavy salt water, while the light, fresh water rides above it. And the Bosphorus is not the only door of its kind on the path, only the first. Beyond it lies another small sea, the Sea of Marmara, a holding chamber between the two great seas. And beyond Marmara lies a second strait, the Dardanelles, the final narrow gate that opens at last onto the Mediterranean proper. So the chain runs like a series of locks, like rooms connected by narrow doors. The Black Sea, then the slim thread of the Bosphorus, then the small sea of Marmara, then the slim thread of the Dardanelles, and only then the Mediterranean and the open world. A long, narrow, winding path, all of it pinched at the throat by those two slender straits, and that pinching, that near enclosure, that fact that the only way in or out is through doors so narrow, is the whole secret of why the Black Sea is the way it is. Because here is what those two layers do, the light, fresh sea on top and the heavy salt sea below. They settle, they separate, and once separated, they refuse to mix. The boundary between them has a name. Scientists call it the halocline. Halo from the old word for salt, the same root that gives us the word for the white crystals you sprinkle on your supper, and cline from the word for a slope or a gradient, a place where something changes as you move through it. The halocline, the salt slope. It is the depth at which the saltiness of the water changes sharply, where you pass in a short vertical distance from the fresher, lighter water above to the saltier, denser water below. And because saltiness controls density, and density controls what floats and what sinks, the halocline is also the boundary of density, light above, heavy below. And a boundary like that between light water resting easy on top of heavy water is one of the most stable arrangements in all of nature. It is the milk and the cream. It is the oil and the vinegar in the still jar. It does not want to mix. It actively resists mixing. To mix it, you would have to push the heavy water up and pull the light water down, and water does not do that on its own, any more than a stone leaps upward on its own or smoke pours downward into the fire it came from. So the halocline becomes a lid of pure physics, invisible, weightless, made of nothing, but the difference between fresh and salt, light and heavy. And that lid sits over the deep of the Black Sea and seals it. Above the lid, the surface sea churns and mixes and breathes, stirred by wind and storm and the turning of the seasons, taking oxygen from the air the way it should, alive and bright and ordinary. But the wind and the storms and the seasons can only stir the water above the lid. They cannot reach beneath it. The lid is too strong, the difference in density too great, and so all that surface stirring, all that breathing stops dead at the halocline and goes no further down. The deep water beneath the lid is never stirred. It is never lifted to the surface to take a breath, and the surface water, with its precious dissolved oxygen, is never carried down to refresh the deep. And so the deep sits there, sealed, trapped beneath its lid of fresh water, and the small things that live in it, in the time before it died, used up the last of its oxygen, breath by breath, the way a sleeper in a sealed room uses up the air. And there was nothing and no one to open the door and let new air in, because the door is shut, the lid is fast, the two seas will not mix. And once the oxygen was gone, it was gone for good. And the deep went still, and the deep went dead. That is the why. That is the answer to the third question. The Black Sea is dead in its depths because it is two seas pretending to be one, a light, fresh sea floating on a heavy salt sea with a lid of pure density sealed between them. And because that lid will not lift, the deep cannot breathe, and what cannot breathe, in the end, cannot live. And now you can begin to feel the weight of that first loop I left in your hand, the one about the water that has not touched the air in over 1,000 years. Because now you know why. It is not waiting for a storm to stir it back to the surface. No storm reaches it. It is not waiting for a current to lift it to the light. No current can lift it. It is sealed beneath a lid it cannot pass, in a basin whose only door to the wider ocean is a thread of water 700 meters wide, and the only new water that ever reaches the deep is more heavy salt water sliding in along the bottom, which only adds to the trapped deep rather than freeing it. So the deep water just stays. And it stays. And it stays. And the years pass over the surface of it, the bright surface that knows nothing of the dark beneath it, and down below, in the sealed and breathless dark, nothing changes at all. We have only just begun to go down, we have crossed the line where the oxygen ends, and we have understood at last why it ends and why it never comes back. But we have not yet asked what fills the deep instead, in the place where the oxygen used to be, and the answer to that is stranger than the silence. And we have not yet found the river that runs along the bottom of the sea, the heavy salt inflow that does not simply spread out and settle, but instead, astonishingly, carves itself a channel and flows, with banks and bends and falls, a hidden river inside the sea. And we have not yet asked how long exactly the deep water lingers before it is renewed, the precise number of years it lies sealed in the dark. And when I tell you that number, the first loop will close, gently, like a door easing shut in a far room of a quiet house. But all of that is for the slow descent still to come. For now, just rest here, at the edge of the lid, at the halocline, at the boundary between the two seas. Above you, the light, below you, the dark, and between them, holding them apart, holding them forever apart, nothing but the simple and unbreakable fact that fresh water floats and salt water sinks, and that some boundaries, once they form, do not let go, and so we go down. Not with a rush, not with any of the urgency that belongs to the bright world above, but slowly, the way the water itself moves in this place, which is to say, almost not at all. The descent below the halocline is less like falling than like settling, like a stone that has given up on resistance and simply allows the dark to receive it. There is no violence in it, there is only the slow and continuous exchange of one world for another. The question we left hanging above the line was a simple one. Why doesn't the deep water mix? And the answer we arrived at was also simple, in the way that the most fundamental things in nature are simple once you find the hinge on which they turn. The fresh water floats, the salt water sinks, and the gap between them is not a gap at all, but a wall, a halocline, a shelf of density so steep that the two layers behave not as parts of a single sea, but as two separate bodies of water that happen to share an address. They do not visit each other, they do not send messages through the interior. They exist in the same basin and ignore each other entirely. The way two neighbors in a very old building can live their whole lives above and below without once meeting on the stairs. But this is where the story becomes genuinely strange. Because you might imagine that the deep water, even if it cannot receive oxygen from the surface through mixing, might at least be refreshed from below, from the inflow that enters through the Bosphorus, the salt-heavy Mediterranean water that pours in as an undercurrent and adds itself to the deep. And in a way that does happen, but the salt water that enters from the Mediterranean does not arrive gently. It does not simply diffuse across the threshold and spread out evenly across the basin floor. It does something that oceanographers, when they first suspected it and then confirmed it, found almost impossible to describe to anyone without a pause of silence first. It flows, not metaphorically, not in the loose sense in which we say that a gas diffuses or a current drifts. The Mediterranean inflow, as it pushes through the narrow throat of the Bosphorus and tips over the sill into the Black Sea, does something that subterranean rivers do, something that rivers on land do. It carves itself a channel, it follows a path, it has banks, and those banks are higher on one side than the other. It bends. It has levees, the low ridges of sediment pushed aside over time, the way a river on a floodplain raises its own banks as it goes, and where the terrain drops away abruptly, where the seafloor descends in a sudden step, the dense salt water pours over the edge in an underwater waterfall. A falls with no spray, no sound, no light, just the slow and massive weight of heavy water tumbling in absolute darkness over a lip of rock and sediment into deeper dark. This was not something anyone guessed. It was not predicted from the physics, not because the physics forbade it, but because the detail of the seafloor topography was not known. And without knowing where the channel runs, there is no way to know it is a channel. It required someone to go down and look down. And in 2010, a survey led by researchers from the University of Leeds did exactly that, mapped the Bosphorus outflow channel in detail, and what they found was, by any measure, one of the great waterways of the world, not because of where it runs, but because of what it carries. The volume of water moving through this submarine channel, if you were to lift it up and set it on dry land, would place it among the largest rivers on Earth by rate of flow. If it were on the surface, you would name it. You would build cities on its banks. It would appear on every atlas and every child's geography lesson as one of the defining features of the planet. But it is not on the surface. It is 300 meters beneath the surface of the Black Sea, winding in complete darkness along the seafloor, and almost no one knows it is there. Think of it this way. Imagine you are standing on a high cliff above the sea, watching a river empty into the water below. The river is brown with sediment, thick with fresh water, and where it meets the salt water there is a visible boundary, a seam, a line where two colors press against each other. Now imagine that the salt water is not simply sitting there receiving the river, but has its own river moving beneath the surface, a river of denser water flowing in the opposite direction, invisible from above, carving its way along the bottom in the opposite direction, carrying its load of dissolved salt inland and downward, bending around the contours of the buried landscape as if it had always known the way. That is what is happening in the Bosphorus, and it is happening right now in the dark as you lie here listening. The channel eventually fans out as rivers do when they reach a wide plain, when the constraining walls fall away and the flow loses its sense of direction and spreads across the flat. The Mediterranean inflow spreads across the abyssal plain of the Black Sea, adding its dense salt to the deep water that is already there, deepening the stratification, making the bottom layer denser still, pressing the halocline upward from below, as if to make its claim on as much of the basin as it can. And the fresh water above presses back, fed by the rivers, fed by the rain, fed by the steady drainage of a third of a continent. Two rivers, in other words, one visible, one invisible, one celebrated, one unknown, both flowing through the same narrow gate at once in opposite directions, neither impeding the other, each locked to its own layer of density, each following the law that gives it its nature. The heavy one goes down, the light one rises. They pass each other in the Bosphorus every second of every day, the outflow at the surface and the inflow beneath it, and they have been doing this for longer than any human record reaches. And neither of them in the end can save the deep. Because here is the thing about the Mediterranean inflow that adds salt to the bottom. It is already depleted of oxygen by the time it arrives. The journey through the Bosphorus is not long by the standards of a river's travel, but it is long enough, and the biological demand for oxygen in the narrow, semi-enclosed Sea of Marmara between the Black Sea and the open Mediterranean is high enough that the water entering the Black Sea's deep is not carrying a meaningful supply of the gas that the deep needs. It brings salt, it brings density, it deepens the stratification, but it does not bring rescue. It brings more of what the deep already has, and the deep already has everything it needs to remain exactly as it is. This is why oceanographers use the word miromictic rather than simply stratified. Stratified is the word for a lake or sea with layers, temperature-driven perhaps, or seasonally driven, or density-driven. Lots of bodies of water are stratified, but miromictic comes from two Greek roots, meros meaning part and miktos meaning mixed, and the prefix is negating. It means a body of water whose layers have ceased to mix, not just in the way that a lake stratifies in summer and turns over in autumn, but permanently, enduringly, in a way that does not reverse with the seasons or the centuries. The Black Sea is the largest miromictic body of water on Earth. It is stratified not for a season, but for geological spans of time, and the deep layer has not genuinely communicated with the surface in longer than any living thing's lifetime, by a margin of many such lifetimes stacked on top of each other. How long precisely? This was the open loop left hanging from the beginning, the first promise made in the early minutes. Something down there has not touched air in over 1,000 years. Now we can pay it off properly with the care it deserves. Oceanographers estimate the residence time of the deep Black Sea water. The average length of time a parcel of water spends in the deep layer before it is finally replaced or renewed. In centuries. Some estimates are shorter, some are longer. The range that emerges from the surveys and the tracer studies and the modelling is broad and not agreed upon with great precision, which is itself an indication of how complex the dynamics are. But the figures that appear in the scientific literature range from several centuries to over 1,000 years, and in some cases higher. A parcel of water sitting at the bottom of the Black Sea may have last been in contact with the atmosphere before the Norman conquest of England, before the great cathedrals of Europe were built, before the Mongol expansion reshaped the Eurasian steppe. The water has been sealed in that darkness since a time so remote that almost nothing survives from it at the surface except stone and text. Sit with that for a moment. The water in the deep Black Sea, the water that has no oxygen, that has never been disturbed by a storm since the age of Crusaders, is not water that was oxygen-free from the beginning. It was water that once, at some point long ago, sat at the surface. It was in contact with the sky. It absorbed oxygen the way all surface water does, dissolving the gas from the air at the interface, and then something carried it down, perhaps a convective overturn, in a much earlier time when the stratification was not yet fully established, and it descended, and the lid closed over it, and since then it has been converting itself slowly and steadily from a parcel of oxygenated water into something else entirely. The oxygen was consumed, and the consuming of it began a chain of transformation so thorough and so strange that by the time you reach the bottom of that chain, you are no longer in a world that resembles any ocean you have ever imagined. We are not there yet. We are still in the descent, still passing through the boundary itself, and the boundary deserves its own slow moment of attention before we cross it. It is not a sharp line. Nothing in nature that exists at the scale of a kilometer of water is truly sharp, and the boundary between the oxygenated upper sea and the anoxic deep is no exception. Between the oxic layer and the fully anoxic deep lies a zone that oceanographers call the suboxic layer, or, when they are being more precise about the chemistry of what is happening, the redoxcline. Redox is a word compressed from reduction and oxidation, the two directions in which electrons travel in chemical reactions, and the cline suffix comes from the same root as incline, meaning a gradient, a slope. The redoxcline is the slope along which the chemistry of the water changes from one regime to another, from a place where oxygen mediates all the significant reactions to a place where something else entirely takes over. In the suboxic layer, oxygen is nearly but not quite gone. There is not enough to sustain most of the aerobic life that thrives above, but there is also not yet the full concentration of hydrogen sulfide that defines the deep. It is a transitional zone, a chemical no man's land, and it is one of the most intensely studied features of the Black Sea precisely because it is where the most interesting and complicated microbial negotiations happen. Different species of bacteria and archaea occupy different niches within this narrow column of water, each exploiting a slightly different position on the gradient, each running a slightly different chemistry, each extracting energy from the transaction between what is above and what is below. At the very base of this transition, where the suboxic layer grades into the fully sulfidic water below, there is something that scientists have called the bacterial plate, or more precisely, the chemocline community, though the word plate is in some ways the more evocative one because it suggests exactly what it is: a thin, dense layer of microbial life, almost a membrane, suspended in the water at the precise depth where two chemistries meet, where the last trace of oxygen or nitrate from above intersects with the first rising wisps of hydrogen sulfide from below, and where certain extraordinary microorganisms have found a way to make a living from the encounter. The most remarkable of these are the green and purple sulfur bacteria. These are among the most ancient forms of life on Earth, organisms whose basic biochemistry predates the arrival of oxygen in the planetary atmosphere by a long margin, organisms that learned to photosynthesize before photosynthesis meant what it means now. In the world we are most familiar with, photosynthesis is the process by which plants and algae use sunlight to split water molecules, releasing oxygen as a byproduct, and using the hydrogen to build sugars. It is the process that oxygenated our atmosphere and made complex animal life possible. But that version of photosynthesis is a relatively late invention in the history of life. Before it, there was another version, used by organisms very like the green and purple sulfur bacteria that split not water but hydrogen sulfide. It still uses light, it still uses carbon dioxide, but instead of releasing oxygen, it releases sulfur. Instead of consuming the compound that makes animal life possible, it consumes the compound that makes animal life impossible. And it does so at the chemocline of the Black Sea right now, in the thin, luminous darkness where light from above barely reaches the sulfide rising from below, using a chemistry that evolution arrived at before the world as we know it existed. This is one of the reasons oceanographers regard the Black Sea with something more than ordinary scientific interest. It is not simply an interesting large lake with a chemical peculiarity. It is a window. It is a place where conditions that prevailed across much of the global ocean in deep geological time, conditions called euxinic, a word derived from the ancient Greek name for the Black Sea itself, Pontos euxeinos, the hospitable sea, are still present and accessible and alive. Euxinic conditions, sulfidic, anoxic, permanently stratified, metabolized by sulfur bacteria at the boundary and by anaerobic communities below. These are the conditions that may have prevailed across vast swathes of the ancient ocean during what geologists call ocean-anoxic events, episodes in deep time when the ocean's oxygen balance tipped catastrophically and whole ecosystems collapsed. By studying what is happening in the Black Sea's chemocline today, scientists have a living analog, a working model of what the chemistry of those ancient oceans may have looked like in their interior. This is why the word unsettles is the right word for what the Black Sea does to the scientists who study it. It is not that the sea is frightening exactly. It is that the sea is too old. It contains chemistry that should be in the past, preserved in rock and inference, and instead it is right here, present and current, running its ancient reactions in the dark 150 meters below a surface where ships carry cargo and seabirds wheel in the afternoon light. It is the uncanny quality of the thing, the juxtaposition of the ordinary and the deeply primeval visible in the water column of a single sea. The green and purple sulfur bacteria are named for their pigments, the biological machinery they use to capture whatever light reaches them. Purple sulfur bacteria tend to occupy slightly shallower positions in the chemocline where more light is available. Green sulfur bacteria, whose chlorosomes, the light-harvesting structures inside their cells, are among the most efficient light capture systems known in biology, can survive at lower light levels and are found deeper in the gradient. They are adapted to function in near total darkness, straining the last photons out of a water column that has already absorbed almost everything the sun sent down. Both groups are running the ancient pre-oxygen photosynthesis using H2S as their electron donor, releasing sulfur rather than oxygen, building their cell mass from carbon dioxide in the cold dark, and living as they have lived for something like 3 billion years in conditions that would kill almost anything else. Below them, below the chemocline, below the suboxic layer, below the last trace of oxygen, below the last wisp of light, the character of the water changes again, and the life that exists there becomes stranger and simpler, and in some ways more purely alien than the sulfur bacteria at the boundary. In the fully anoxic, fully sulfidic deep, the community of microorganisms is dominated by anaerobic archaea and bacteria running the metabolisms of the oxygen-free world, fermenting, reducing sulfate, producing methane, cycling sulfur in loops that have no need of the sun, no need of the surface, no connection to the bright world 2,000 meters above. They are not suffering down there in any meaningful sense. They are simply living as they always have in the chemistry they evolved for. The sea that is dead by every measure we apply from the surface is, by its own standards, very much occupied. There is methane in the deep water too, produced by the archaea as a byproduct of their anaerobic metabolism, and the basin floor has cold seeps where methane rises through the sediment and enters the water column, and around these seeps are microbial mats, bacterial communities built on the chemosynthesis of methane rather than sulfide, and carbonate structures precipitated from the reactions, and the whole complex ecology of the deep seep environment playing out in the absolute dark. None of this is visible from the surface, none of it announces itself, but it is there, and it has been there, in one form or another, since the deep water settled into its current chemistry, and it will be there long after the ships on the surface have finished their journeys and gone wherever ships go. There is a speculation, and it is important to hold it as a speculation, not an established fact, that has been discussed among researchers who think about the geochemistry of the basin. A question about what would happen if some large and sudden event, a significant submarine landslide, a strong enough seismic disturbance, something of genuine geological magnitude, were to disturb the stratification and bring the deep water into rapid contact with the surface. The hydrogen sulfide dissolved in that water and the methane are present in enormous quantities. The gas reservoir is real, But the idea that this represents an imminent or even a plausibly near-term hazard belongs more to the literature of geological speculation than to any current risk assessment, and it should be heard in that register as a thought experiment about what the basin contains, not as a prediction about what it is likely to do. The stratification is stable. The halocline is strong. The dynamics that maintain it are persistent and well understood. This is a basin where things stay as they are for centuries, not a basin on the edge of sudden change. The science is careful here, and we should be careful too. What is not speculation and what carries no need of caveat is the thing that deep water does passively, without effort, without intention, without any of the dramatic physics of a gas release. It simply sits there, airless and sulfidic and utterly still, and in sitting there, it preserves. This is the great inversion at the heart of the Black Sea's story, the reversal that the angle of this whole descent has been building toward. The thing that makes the deep water lethal is the absence of oxygen, the presence of hydrogen sulfide, is the same thing, the exact same thing that makes it the finest natural archive the world has produced for organic materials. Wood, rope, fabric, carved wood. The iron fittings of ancient vessels. These things survive on the oxygenated seafloor of every other ocean on Earth for, at most, a few centuries before they are consumed. Bacteria eat the organic matter, marine invertebrates burrow through it, and most devastating of all, in the oxygenated ocean, the shipworm thrives. The shipworm, Teredo navalis is its proper name, is not actually a worm. It is a bivalve mollusk, a relative of the clam and the oyster, but elongated beyond recognition into something that looks more like a pale, soft tube than anything you would associate with a shell-bearing animal. What it does is bore. It bores into submerged wood with the tiny shell valves at its front end, rasping through the timber with a rotary motion, and it grows as it bores, extending its soft body through the tunnel it has made, and over time, given a suitable piece of submerged wood, it will reduce it to something like a sponge, a honeycomb of hollow tubes that was once solid timber. A hull, a deck plank, a mast. Given time and the presence of Teredo navalis, these things vanish. Ancient wrecks on the oxygenated seabed are, in most of the world's oceans, skeletal at best and invisible at worst. The wood is simply gone, consumed by the animal that has been consuming it for as long as there have been oceans. Teredo navalis cannot live without oxygen. Like most animals, it breathes, and in the anoxic, sulfidic deep water of the Black Sea, there is no oxygen to breathe, and the hydrogen sulfide that saturates the water is, for any aerobic organism, simply a poison. The shipworm does not descend into the deep Black Sea. Nothing with gills or lungs or any aerobic respiratory system descends into the deep Black Sea, and so the wood that sinks to the deep Black Sea does not meet the shipworm. It does not meet the fungi that would consume it in an oxygenated environment. It does not meet most of the bacteria that would metabolize it. It settles in the cold, still, lightless dark, and it is held there, and centuries pass, and it remains. Masts, rudders, rowing benches, coils of rope, carved decorations on a merchant vessel's hull. The tool marks left by a shipwright more than 2,000 years ago on a plank he was shaping to fit a keel. All of it, intact, preserved not by any human technology, not by any deliberate act of conservation, but by the same chemistry that kills everything else that might want to reach it. The Black Sea Maritime Archaeology project, known by its initials as Black Sea Map, was a multinational expedition that ran between 2015 and 2017, led by the University of Southampton in partnership with institutions and researchers from several countries. It used deep-water remotely operated vehicles, ROVs, the kind of submarine robot that can descend to 2,000 meters and operate cameras and sampling equipment with precision in the dark, and it used photogrammetry, the technique of building three-dimensional models from overlapping photographs, to document what it found on the seafloor without disturbing it. And what it found over the course of those 3 years was a museum. More than 60 shipwrecks spanning roughly 2,500 years of maritime history, Byzantine vessels with amphorae still in their holds, Roman trading ships, Ottoman vessels whose construction details, preserved intact, could be compared directly with historical records and illuminated questions about how those ships were actually built that no scholar had been able to answer from documents alone. Each of them resting in the dark, unharmed, waiting with the patience of objects that have no awareness of waiting for the ROV's lights to reach them. The oldest, the one that stopped the researchers in their tracks, the one that became, when the results were published and then reported in the wider world, the image that the Black Sea Map Project would be known by. A Greek merchant ship dated by radiocarbon analysis of a small sample taken from its timber to approximately the 4th century before the Common Era, roughly 400 years before the birth of Christ. 2,400 years in the dark, give or take the uncertainty of the dating, sitting at approximately 2,000 meters depth off the Bulgarian coast, and intact. The mast was still standing, let that settle. A wooden mast rising from a wooden hull on a ship that last saw daylight in the age of Aristotle, in the era when the great Greek city-states were arguing about philosophy and building their navies and trading wine and oil and grain across the Aegean and the Pontos, the Greek word for the sea we are now descending through. And that ship, that wooden instrument of an ancient world's commerce, had its mast still vertical, still in place, still attached to the hull in which it had been stepped by a shipwright whose name no document has preserved, in a port whose stones have long since been turned to other purposes. The rudders were there, the rowing benches, and the form of the hull, the shape of the ship, matched something that had previously existed only as a painted image, not as an object. The ship depicted on a vase in the collection of the British Museum known as the Siren Vase, a vessel decorated with a scene from the myth of Odysseus passing the Sirens, tied to his mast while his crew rows past the deadly rocks. The image on that vase shows a particular kind of Greek merchant vessel, a shape that scholars had studied as an artistic convention, a painted form. The ship on the Black Sea floor is, as far as the researchers could determine, the actual thing, not the image, the object, the real timber assembly that the image was a representation of. The Siren Vase and the wreck at 2,000 meters, separated by a painted surface and 24 centuries, confirming each other across the longest distance a comparison can travel. A small sample of the wood was taken for carbon-14 dating to confirm the age that the style and construction suggested. The result came back consistent with the 4th century BC, and then the ship was left in the dark at 2,000 meters in the water that has preserved it for 2.5 millennia and will continue to preserve it for as long as the stratification holds and the chemistry remains what it is. There is no technology we currently have, no conservation method, no controlled environment we can build on land that would preserve that ship better than the anoxic deep water of the Black Sea is preserving it right now for free in the dark, just by being what it is. The thing that kills everything down there is the same thing that saved it. And this is the reversal that sits at the center of everything the Black Sea does that unsettles the people who study it, because you cannot hold in your mind simultaneously the image of a sea whose deep water is a reservoir of sulfide and anoxia, a place inhospitable to virtually all of the life we recognize, and the image of that same sea preserving, in perfect stillness, the most complete record of ancient human seafaring that exists anywhere on the planet. The two images push against each other. They contradict each other in the way that living and dead contradict each other. And yet they are the same place, the same water, the same chemistry. The poison is the preservative, the death is the archive, the darkness that nothing can survive is the very thing in which everything survives. We are deep now. We have crossed the halocline, descended through the suboxic layer, past the chemocline where the green and purple sulfur bacteria run their ancient chemistry in the last light, and entered the fully anoxic, fully sulfidic dark, where the only life is microbial and the only sounds, if you could hear at this depth, would be the slow settling of sediment and the cold convection of heavy water across the abyssal plain. Above us, the bacterial plate. Above that, the redoxcline. Above that, the halocline. Above that, 150 meters of oxygenated, living, wave-disturbed sea. And then the surface. And then the sky. Two worlds stacked. Not speaking. The bacteria at the boundary work their ancient chemistry, and the sulfide-saturated deep holds its stillness, and the wooden ships rest in the dark as they have rested since before the Roman Empire was a memory, and the water that last touched the air in the age of the Crusades sits sealed and unchanged in the basin that was carved by the last ice age and has been held in its current form by the halocline ever since. But the question of how it came to be this way will be how the Black Sea arrived at this particular chemistry, this particular stratification, this particular combination of fresh and salt and sulfide and stillness. That question reaches further back than the ships, further back than the Greeks, further back than any human record, into a time when the sea itself was something entirely different from what it is now, and the answer to it is still, after decades of research and significant argument, not fully agreed upon. That is where we are going next, into the question of the flood. And here, in this deepest and most absolute dark, is where the chemistry of the Black Sea becomes something stranger than almost any body of water on the surface of the earth. The water below the chemocline is not simply empty. It is not merely the absence of oxygen and light and the fish and the plankton and the slow drift of organic matter that characterize the surface world. It is full, it is saturated with something, and that something is hydrogen sulfide, the same compound that gives rotten eggs their particular, unmistakable character, the same gas that you would recognize immediately and recoil from if it were present in any concentration your nose could detect at the surface of the world. Hydrogen sulfide is produced by a particular group of microorganisms called sulfate-reducing bacteria. To understand what they do, it helps to think about what ordinary aerobic life does, the kind of life you and every animal and most visible organisms on Earth rely upon. Aerobic organisms take in oxygen and use it as a kind of chemical partner, a receiver of electrons in the long chain of reactions that releases energy from food. Oxygen is the final acceptor in that chain. Without it, the chain breaks. Without it, ordinary life cannot proceed. But sulfate-reducing bacteria found another partner long before oxygen became abundant in the Earth's atmosphere, in the ancient chemical environment of the early planet. They use sulfate instead of oxygen. Sulfate is a compound found dissolved in seawater, and these bacteria strip the oxygen away from the sulfate molecule in a slow, elegant metabolic process, releasing energy for themselves and releasing, as a byproduct, hydrogen sulfide. They have been doing this for perhaps 3 billion years. They were ancient when the first animals appeared. They are ancient now, and the Black Sea's deep water is their world, and they have been working in it for long enough that the sulfide has accumulated to concentrations that would be immediately lethal to virtually any organism that breathes oxygen, any organism that swims or crawls or drifts or attaches itself to substrate in the way that the creatures of the upper sea do. The concentrations of hydrogen sulfide in the Black Sea's deep water increase with depth. The deeper you descend below the chemocline, the richer the sulfide becomes. Near the bottom of the basin, on the Euxine abyssal plain, at depths approaching 2,000 meters, the concentration reaches its highest values. Scientists who have pulled water samples from these depths describe the smell when the containers are opened at the surface, a dense, pervasive, organic reek that is unmistakably biological and ancient and entirely alien to the open air. It is the breath of a world that has not touched the atmosphere in centuries. In some parts of the basin, the water at depth has a residence time estimated in centuries, and in others, the estimates reach beyond 1,000 years. The water sitting at the bottom of the Black Sea today may last have been in contact with the atmosphere in the era of the Crusades, or earlier, or perhaps in the time before the Norman conquest of England, settling downward through the halocline from a salt inflow that entered through the Bosphorus in an age when the world above the sea looked almost entirely different from the world it looks now. Methane is present as well. The Black Sea's deep sediments host numerous cold seeps, places where methane gas migrates upward through the seafloor and enters the water column, forming plumes that rise into the anoxic water and, in some cases, approaching the chemocline. On the slopes of the basin, methane-derived carbonate structures have formed over long periods of time, the kind of mineral accretions that build up when methane reacting with sulfate in the sediment produces carbonate, leaving behind hard, irregular formations on the floor. Microbial mats coat portions of the slope sediments, pale and strange communities of organisms that are metabolically active and utterly invisible from the surface, doing their chemistry in the dark and the pressure without any connection to the sunlit world above. There are researchers who have raised a more speculative question about all of this accumulated gas. The dissolved hydrogen sulfide and the methane represent, taken together, an enormous stored chemical reservoir, and the question that some scientists have discussed carefully and with appropriate hedging is what would happen to that reservoir if it were suddenly disturbed. A major submarine landslide on the slopes of the basin, or a significant seismic event, could theoretically displace large volumes of deep water or release gas suddenly from the sediment. What that might mean for the chemistry of the basin or for the atmosphere above it is a question that remains hypothetical. It has not been modeled in any way that produces confident predictions, and the geological record does not show clear evidence of catastrophic past releases of this kind. Scientists who discuss it are careful to frame it as a possibility worth understanding, not as an established danger or an imminent threat. The Black Sea is not a bomb. It is a repository, ancient and deep and still, and the gas within it has been accumulating for millennia without incident. But the reservoir is real and the question is honest, and it is the kind of thing that makes the basin interesting to people who study large-scale chemistry and who want to understand what the sea is capable of on the very longest timescales. It belongs here, in an honest account of the basin, as long as it is kept in its proper place, which is the realm of the carefully uncertain, not the realm of the dramatically alarming. What is not speculative, what is documented, and what is one of the most quietly remarkable facts about the Black Sea is the relationship between that sulfide-saturated dead zone and the things that have fallen into it over the course of human history. Begin with the simplest version of the logic. Wood in the ocean does not last. The reason it does not last is not primarily that salt water dissolves it or that the chemistry breaks it down. The reason is biological. There is a creature called Teredo navalis, the shipworm, and despite its name, it is not a worm at all, but a bivalve mollusk, a relative of clams and oysters, though nothing in its appearance would suggest the family resemblance. It is long and pale and cylindrical, with a small pair of shells at its head end that it uses like a drill, boring into submerged wood and tunneling through it, consuming the cellulose with the help of symbiotic bacteria, and lining its tunnels with a hard mineral secretion. A piece of timber left in oxygenated seawater will be found by Teredo navalis within weeks. Within months, it will be riddled with tunnels. Within years, it will be reduced to a fragile shell of its former structure, held together by the mineral linings of the borings until the whole thing collapses into sediment. Teredo navalis has been the great destroyer of wooden ships throughout maritime history. It was a known hazard to ancient sailors who coated their hulls with various substances to slow it. It has eaten the evidence of thousands of years of seafaring. It has consumed the wrecks of ships that carried grain across the ancient world, ships that traded between civilizations, ships that carried soldiers and ambassadors and pilgrims and merchants. It has eaten the hulls before any archaeologist could reach them, before the sea floor had any way of preserving what fell to it. The wooden history of human seafaring exists, for the most part, only in fragmentary form, because the sea below the waterline is full of Teredo navalis, and Teredo navalis is thorough. But Teredo navalis breathes oxygen. It is an aerobic organism. It cannot survive without dissolved oxygen in the surrounding water, and the Black Sea below approximately 150 meters has no dissolved oxygen at all. This is the inversion at the heart of everything, the same chemistry that kills, that makes the deep Black Sea a void in which almost nothing can live. The same sulfide-saturated, oxygen-free water that has accumulated over centuries in the basin's sealed lower layer is also what has preserved everything that fell through it. Below the anoxic boundary, below the chemocline and the bacterial plate and the redoxcline, there is no Teredo navalis. There is no boring worm of any kind. There is no aerobic organism capable of consuming wood or rope or leather or any of the organic materials from which ancient ships were made. There is only the stillness and the cold and the slowly accumulating sediment and the chemistry of the deep, and whatever falls to it is kept. The logic of this is simple once you understand it. The wood does not decay because decay, in the biological sense, requires organisms, and organisms require oxygen, and oxygen does not exist below the boundary. The chemical decomposition of wood is also slowed in cold, deep water, where the temperature is low and the pressure is high, and the kinetics of chemical reactions are sluggish. But the biological decay, which is far faster than the chemical, is simply not happening. A ship that sinks through the surface water and through the oxic layer and passes the chemocline and comes to rest on the floor of the deep Black Sea is a ship that has been placed in the most effective, preservative environment on the surface of the planet. Not because anyone designed it to be, not because of any intention, but because the accident of the basin's chemistry, the halocline that traps the dense water and prevents the deep from ever ventilating, created a set of conditions that are lethal to organisms and therefore perfectly preserving of organic artifacts. Scientists and archaeologists understood this in theory for some time before they were able to test it directly. The deep floor of the Black Sea was difficult to reach, and the technology capable of sending cameras and sampling equipment to depths of 2,000 meters was not widely available until the late 20th century. The hypothesis that ancient ships might be preserved down there was compelling, and it circulated in archaeological and oceanographic literature, but the hypothesis needed confirmation. Beginning in 2015 and continuing through 2017, a multinational research program called the Black Sea Maritime Archaeology Project, affiliated with the University of Southampton and involving researchers from multiple institutions and countries, conducted systematic surveys of the deep Black Sea using remotely operated vehicles, the unmanned submersibles equipped with cameras and sampling arms and sonar systems that allow exploration at depths no diver can approach and no crewed vessel can easily investigate. The project used photogrammetric survey methods, building detailed three-dimensional models of the seafloor and of the objects resting on it from overlapping images taken by the ROVs at close range, so that each wreck could be documented in extraordinary detail without being disturbed. What they found exceeded even the optimistic predictions. Over the course of the survey, the Black Sea Maritime Archaeology project documented more than 60 shipwrecks, 60 distinct vessels resting on the floor of the deep basin, spanning approximately 2,500 years of maritime history. Byzantine ships from the medieval period, Roman vessels, Ottoman trading ships, earlier vessels whose construction places them in periods so remote that their builders were working from traditions of shipbuilding that have left no living descendants in the modern world. All of them resting in the deep anoxic water in varying states of preservation, but all of them preserved far beyond what would be possible in any oxygenated sea. The variation in condition is itself a record. Ships resting in shallower water in the upper margins of the anoxic zone, where oxygen is lowest but not entirely absent, show more deterioration than ships resting in the full deep. The deeper the vessel, the better the preservation, a gradient that maps directly onto the chemistry of the water column. The data from the survey are, in that sense, a controlled experiment conducted by history over thousands of years, each shipwreck a data point demonstrating the relationship between anoxic conditions and organic preservation. But among those 60-odd wrecks, one stands apart from all the others, and it is the one that, when its description first circulated in the scientific and popular press, seemed almost impossible to believe. Off the Bulgarian coast of the Black Sea, at a depth of approximately 2,000 meters, resting on the floor of the deep basin in what is effectively the middle of the anoxic zone, the survey found a Greek merchant ship. Its age was established by the form of its construction, by the typology of the vessel as read from the detailed photogrammetric models, and then confirmed by a small sample taken for radiocarbon, carbon-14 dating, the technique that reads the decay of a specific isotope to establish how long it has been since an organic material last exchanged carbon with the atmosphere. The ship dates to approximately 400 BC. It is, as of its discovery, the oldest intact shipwreck known to science. It is approximately 2,400 years old. And it is intact, the mast is still standing. Pause on that for a moment because the significance of it takes a moment to settle. The mast of a wooden ship is not a low, heavy structure protected by its own mass. It is a tall, projecting vertical element exposed to the forces of the sinking and the settling, the thing you would expect to be knocked aside or collapsed or broken in the process of a ship going down. And yet on the floor of the Black Sea, 2,000 meters down, in water that last touched the atmosphere during the lifetime of Plato, the mast of a 4th century BC Greek merchant ship is standing. The rudders are present, the rowing benches survive, the carved decoration on the hull, the marks left by tools in the hands of shipwrights working in a Greek port. At the time when the Persian Empire was still a living thing, those marks are readable. The rope, organic material, among the most fragile and perishable of all the artifacts that would be found aboard a ship, is coiled. The physical form of the vessel is so complete that archaeologists could read its construction method, could identify the traditions of boat building from which it came, could compare its shape and its proportions with the artistic record. And that comparison produced one of the details that gives the whole story a particular resonance. The form of the ship, as reconstructed from the photogrammetric survey of the wreck, closely matches the ship depicted on a particular painted vase held in the British Museum. The vase is called the Siren vase, and it carries a famous image from Greek mythology, the scene in which Odysseus, bound to his mast, listens to the song of the sirens without being able to act on the compulsion they create in him, while his crew, their ears stopped with wax, rows the ship past the danger. The ship in that painting is the kind of merchant vessel that Greeks of that era would have known well, the kind of vessel that carried grain and wine and oil and timber across the ancient sea. And the ship on the floor of the Black Sea is, apparently, that kind of vessel, recognizable not only from the archaeological record, but from the art of the period in which it was built and sailed and, ultimately, lost. The wreck was surveyed and documented with every tool available to the team. The three-dimensional models were built. The carbon-14 sample was taken from a small piece of wood, carefully selected so as to disturb the wreck as little as possible, and the sample was sent for dating and returned its result. And then the wreck was left in place on the floor of the Black Sea, in the dark, in the anoxic water, in the stillness that has kept it since before Rome was an empire. It is still there now. 2,000 meters down, in the dead layer of a mirror-mictic basin, in water where nothing with lungs or gills can go, the mast of a Greek merchant ship stands in the dark, and the rope is coiled at its base, and the marks of tools from a shipyard of the 4th century BC are visible in the wood if you send a camera close enough to see them. The ship is not in a museum. It is not in a laboratory. It is in its original resting place, which happens to be one of the most perfectly preserving environments on the planet, and it is in better condition than most wooden ships that have been raised and placed in climate-controlled conservation facilities, because the sea itself has been the conservation facility, and the sea has been working for 2,400 years. There are 60 other wrecks down there as well, each of them a window into a particular moment of maritime history, each preserved to whatever degree the depth and the chemistry and the circumstances of its sinking allowed. Byzantine ships with their distinctive construction methods. Roman vessels, some of them possibly carrying the kind of amphora cargoes that archaeologists have recovered in fragments from the oxygenated shallows of other Mediterranean sites, but here, present and intact in the context of the ships that carried them. Ottoman vessels from the centuries when the Black Sea was a lake, effectively, of the Ottoman Empire, the sea over which they had nearly complete control, the sea their fleets used as a private body of water for internal trade and military movement. Each wreck a point of data. Each wreck a preserved moment. All of them together a museum 2,500 years deep, sitting on the floor of the world's largest anoxic basin, tended by sulfate-reducing bacteria and the cold and the dark and the complete absence of the one organism that would otherwise have consumed them all. Teredo navalis does not know the floor of the deep Black Sea. It has never reached it. It works in the oxygenated shallows as it has always worked, boring into the timber pilings of docks and the hulls of vessels that stay in the warm and oxygen-rich surface water. Below 150 meters, below the oxic-anoxic boundary, below the chemocline, its world ends. The world of the ship begins. The relationship between the poison and the preservation is the inversion that makes the Black Sea what it is, the thing that distinguishes it from every other sea, the thing that makes scientists who study it look at it with an expression that is not quite unease but is something adjacent to it, the feeling of encountering a logic that is entirely coherent and yet entirely reversed from what you might expect. The sea that cannot sustain life is the sea that keeps the most complete record of what happened on it. The chemistry that kills is the chemistry that preserves. The void is the archive. The dead zone is the museum. And the museum is vast. The floor of the deep Black Sea extends across the Euxine abyssal plain, a wide, flat, sediment-covered expanse, and the 60-odd wrecks found by the Black Sea Maritime Archaeology project represent the results of a survey covering a fraction of that floor. The total number of ancient vessels resting down there across the full extent of the deep basin is unknown. The survey identified what it identified within the operational range and time of a 2-year project with finite resources and finite coverage. The rest of the floor has not been systematically searched. What is down there across the full 2,000 meters of depth and the full area of the basin remains a question that cannot yet be answered with any precision. It is an archaeological library that has never been read. Most of its shelves have not been reached, and it will remain that way for some time because working at those depths requires equipment and funding and logistical support on a scale that only well-resourced research programs can command, And the Black Sea, for all of its strangeness and all of its scientific interest, has not attracted the kind of sustained, systematic, deep-floor survey that would be required to map it comprehensively. What has been found was found by a dedicated program operating over a specific period in a specific region. The rest waits in the dark, in the anoxic stillness, preserved as it has always been preserved by the same chemistry that has been working in the deep water since the basin arrived at its current stratified state, which is itself a story whose edges are still not fully agreed upon. The water keeps what falls to it. The bacterial plate marks the boundary between the keeping and the consuming. The ships rest below it in the cold dark, in the company of sulfate-reducing bacteria and methane seeps, and the slowly accumulating fine sediment that has been drifting down through the anoxic water for thousands of years, building up in thin, laminated layers on the floor, a record of the basin's history written in chemistry and particle size that sediment core specialists can read, under the right conditions in extraordinary detail. Those laminated sediments are part of the evidence that makes the Black Sea scientifically interesting far beyond the archaeology, because the sediments preserve not just the physical accumulations of the present, but the chemical and biological signatures of the past. And in the past of the Black Sea, encoded in those layers, is the record of a transition that changed the sea entirely, a transition from something it once was to something it now is, a transition whose nature and speed are still, after decades of investigation, among the most actively debated questions in the oceanography and geology of the basin. And that is the question of what happened here in the time before any of those ships sailed this water, in the time before the Greeks gave the sea its name, in the time before any human record begins, when the world above the basin was coming out of the grip of the last ice age, and the relationship between the sea and the ocean it connects to was apparently very different from what it is now. The Black Sea that exists today is a sea with two layers that cannot mix, fed from below by Mediterranean salt and from above by rivers draining a third of Europe, held in its current stratification by a halocline that traps the dense bottom water and prevents the deep from ever breathing. But this arrangement is not eternal. It is not the original condition of the basin. The stratification and the sulfide and the anoxic deep are consequences of the present connection between the Black Sea and the Mediterranean, a connection that routes saltier, denser Mediterranean water through the Bosphorus as a deep undercurrent, building up the saline lower layer over time. And the Bosphorus connection, while it exists now, did not always exist in its current form. And the question of when it assumed its current form and what happened when it did is the question that takes us into perhaps the most contested and in some ways most resonant debate in the history of this basin. Because the last ice age ended gradually but decisively, and when it ended, the ice that had locked up vast quantities of water in the glaciers and ice sheets of the northern hemisphere melted back into the ocean, and global sea level rose, and the geography of the world changed in ways that can still be read in the drowned topography of continental shelves around the planet. What was dry land became shallow sea. What was marginal coast became open water. And the connection between ocean basins that had been restricted or severed during the low sea level of the glacial period was in many cases restored or deepened as the water returned. For the Black Sea, which connects to the Mediterranean only through the narrow passage of the Bosphorus, and then through the Sea of Marmara and the Dardanelles, that rising sea level had, at some point, a decisive consequence. The question that the science has been trying to answer, ever since the oceanographic and geological investigation of the basin became systematic, is what exactly that consequence was, and when it happened, and what the Black Sea looked like before it happened, and how quickly and dramatically the change occurred. The answers that the evidence suggests are partly agreed upon and partly not, And the partly not portion of the question is where the unease of the scientists who study the basin truly lives, not in the sulfide and not in the darkness and not in the wrecks, but in the fundamental question of how the sea became what it is, and whether the answer to that question is as dramatic as some researchers have proposed, or as gradual and undramatic as others insist. This is where, if you are still here, if the dark and the quiet and the slow pace of this descent have not carried you to sleep yet, we are going next. During the last ice age, the Black Sea was not the Black Sea in any sense that we would recognize today. It was a lake, a large lake and an old one, fed by the rivers that still drain into it now. The Danube moving in from the west, the Dnieper and Dniester from the north, the Don from the deeper interior, carrying snowmelt and rain from the vast catchment of what is now Eastern Europe. But the connection to the Mediterranean through the Bosphorus was, during that colder and lower world, either closed or greatly restricted, and so what accumulated in the basin was fresh water, or close to it. A lake where freshwater organisms lived, mussels and snails and other small creatures adapted to low salinity, to the kind of water that a large inland lake holds, the kind of water a river carries down from the mountains and the plains. The sea level of the Mediterranean was, at the glacial maximum, and for thousands of years afterward, significantly lower than it is now. Lower by a great deal. Estimates for the global sea level depression at the height of the last glaciation run to over 100 meters below the present shoreline, and the specific depression in the Mediterranean basin, which connects to the global ocean only through the Strait of Gibraltar, was also substantial. The Bosphorus, which is today a narrow waterway about 700 meters across, at its most constricted, connecting the Black Sea to the Sea of Marmara and then through the Dardanelles to the Aegean and the wider Mediterranean, was at various points during the cold and low period of the glaciation either dry or too shallow to permit any significant exchange of water. The Black Sea sat behind that barrier, accumulating the runoff of a continent, slowly filling or slowly losing water through evaporation, but largely cut off from the salt of the Mediterranean. Then the ice began to melt. Slowly at first, and then with gathering momentum across the millennia that followed the glacial maximum, the great ice sheets of the northern hemisphere released their stored water back into the ocean. The sea level rose. It rose not all at once, but in stages, sometimes faster and sometimes slower, responding to the tempo of the melting, but the overall direction over thousands of years was unmistakably upward. Coastlines that had been dry were inundated. River valleys that had flowed across exposed continental shelf became submerged estuaries. The map of the world's coastlines was redrawn, gradually but irreversibly, by the returning water. And at some point, the rising Mediterranean reached the threshold of the Bosphorus. What happened then? Exactly what happened, and how fast, and with what consequences for the people and creatures that lived around the Black Sea at the time, is the question that has occupied geologists and oceanographers and archaeologists for decades. And it is the question that remains, in its most important dimensions, genuinely and robustly unanswered. The cause pulled from the sediment of the basin floor, the chemical signatures preserved in the muds, the distribution of shells and the isotopic composition of the water recorded in those shells. All of this evidence has been assembled, and it all points toward a real and significant transition. But what it does not yet unambiguously tell us is whether that transition was slow and gentle, or sudden and catastrophic. And that distinction matters enormously, not just for the science, but for everything that may have been remembered and perhaps mythologized about it. In 1997, two marine geologists named William Ryan and Walter Pittman, working at Columbia University's Lamont Doherty Earth Observatory in New York, published a proposal that made the question famous far beyond the community of scientists who had been quietly working on it. Ryan and Pittman had been studying the sediment cores and the seafloor topography of the Black Sea for years, and their reading of the evidence led them to a striking conclusion. They proposed that approximately 7,600 years ago, their figure, sometimes cited as approximately 7,500, the precision of the dating being itself one of the things the debate turns on, the rising Mediterranean had reached and then breached the Bosphorus threshold, and that when it did, the result was not a gradual seeping of salt water into the freshwater lake, but something much more dramatic, a catastrophic inundation, water pouring through the newly opened passage in enormous quantities, as the elevation difference between the Mediterranean and the lower Black Sea lake drove a massive flow through the breach. The freshwater lake, in their model, was significantly lower than the Mediterranean, perhaps by as much as 100 meters or more, and so when the barrier gave way, the Mediterranean water fell into the Black Sea basin with tremendous force, flooding the former lake at a rate that they estimated could have raised its level by as much as 15 centimeters a day. That is not an abstraction. 15 centimeters a day, sustained over months, over years, means that the shoreline moved. It moved inland, steadily, relentlessly across what had been habitable ground. Forests and meadows and the edges of human settlements, if there were any. And there were, because 7,600 years ago was not the deep prehistoric past, it was the Neolithic. People were farming and building and living around the margins of that freshwater lake. All of it, in the Ryan and Pittman model, going underwater. Not in the way of the slow geological changes that reshape coastlines over millions of years, but fast. Fast enough to be witnessed. Fast enough to be survived by running if you were close to the shore when the water began to rise. And Ryan and Pittman went one step further, or at least allowed the speculation. They suggested that this event, this catastrophic flooding of the Black Sea basin, might be the kernel of memory encoded in the ancient flood stories that appear in the early literature of the Near East, most famously in the biblical story of Noah and the Ark, but also in the earlier Mesopotamian versions of the flood narrative, the stories of Utnapishtim and Ziusudra, which predate the biblical text and which describe a great flood sent by the gods that covered the land and destroyed almost everything. The idea that a real flood of this magnitude occurring in or near the cradle of early Neolithic civilization in the Near East and around the northern Fertile Crescent could have left a cultural memory so vivid that it survived thousands of years of retelling and eventually found its way into the foundational texts of the ancient world. That idea was powerful enough and simple enough to travel far beyond the scientific literature. It was a compelling story. It still is. The problem is that the science does not fully support it, and the more carefully the evidence has been examined in the decades since Ryan and Pittman published their hypothesis, the more contested the catastrophic interpretation has become. The cores that provided the primary evidence for the transition are real. There is a layer in the sediments of the Black Sea that records the change from a freshwater or low salinity lake environment to a marine-influenced environment, a sapropel layer, a band of organic-rich sediment, and above and within it the chemical and biological signatures of the transition. The freshwater mollusks, the mussels and snails that lived in the lake, give way in the sediment record to marine mollusks, species that need salt, species that came with the Mediterranean inflow. That change is recorded in the cores. It happened. The question is how it happened, because there are other ways to read the same evidence. Other researchers, examining different cores from different parts of the basin, applying different analytical techniques and different models of what the sea level difference between the Mediterranean and the Black Sea actually was at the relevant time, have reached quite different conclusions. Among the most significant counter-arguments is work associated with Liviu Gheorghiu and other researchers who have argued, on the basis of sedimentological and geomorphological evidence that the transition was not catastrophic but gradual, that the Black Sea was not as low as the Ryan-Pitman model requires, that the water level difference between the basin and the Mediterranean was much smaller, and that the reconnection was therefore a slower, less dramatic process of rising water rather than a sudden, violent flood. In this reading, the sea level in the Black Sea was already relatively close to the Mediterranean level by the time the connection through the Bosphorus was re-established, and the influx of salt water, while real and consequential in its long-term effects on the ecology and chemistry of the basin, did not happen with the speed and violence that Ryan and Pitman proposed. The marine mollusk fauna that replaced the freshwater fauna did not arrive in a single catastrophic pulse in this alternative view, but spread gradually through the basin as the salinity slowly changed. The drowned shorelines that marked the former lower level of the lake were not inundated in a matter of months or years, but over centuries. The change was real, it was significant, but it was, in this reading, the kind of geological change that unfolds on timescales too long to be experienced as a single, dramatic event. Too slow to be witnessed by a human being standing on the shore, too gradual to leave the kind of vivid, traumatic memory that would survive for 7,000 years in the oral traditions of a people and eventually become the story of Noah. The debate has not been resolved. Scientists are still working on it. The cause is still being analyzed. The models are still being refined. The dating of the transition and the estimates of the former water levels are still being argued over in the journals and at the conferences where this work is presented. And this is not a small or trivial disagreement about the details of an obscure geological event. It is a genuine, substantive scientific dispute about the nature of one of the most significant environmental changes in the history of the region that gave rise to the earliest complex civilizations, a dispute with implications not only for geology and oceanography, but for archaeology and for the history of human settlement around the Black Sea basin. Robert Ballard, who is perhaps best known to the wider world as the man who found the wreck of the Titanic in the North Atlantic in 1985, mounted an expedition to the Black Sea in 2000 to look for evidence of the pre-flood coastline. He and his team searched underwater off the coast of Turkey in the shallow waters where the former shoreline of the lower Black Sea lake would have been if the Ryan-Pitman model was correct. And they found things. They found what appeared to be a former coastline, preserved beneath the water. Features of the sea floor that resembled the kinds of structures that form in freshwater and nearshore environments, and what they interpreted as possible evidence of human occupation of that former shore. Structures that might have been buildings. The remnants, perhaps, of a Neolithic settlement that had been inundated when the sea rose. The discovery was reported widely. It was, for a moment, treated by many who heard about it as the confirmation of the flood hypothesis. Here was the drowned world. Here was the evidence that people had lived on the shoreline and been displaced when the waters came. But here, too, the interpretation has been contested. Other researchers have questioned whether what Ballard's expedition found was what it appeared to be, whether the features identified as possible structures were in fact natural formations, whether the evidence of human occupation was as clear as the initial report suggested, whether the location and the depth were consistent with the Ryan-Pitman model or with the alternative gradual rise scenario. The debate about Ballard's findings has unfolded alongside the broader debate about the flood hypothesis itself, and neither has been resolved. What the science has established with a reasonable degree of confidence is this. The Black Sea was once a lower, less saline lake. The Mediterranean reconnected to it as global sea level rose after the last ice age. Marine species colonized the basin as the salinity changed. The present stratification, the two-layer structure with its fresh surface water and its dense Mediterranean-derived bottom water, its halocline and its anoxic deep, developed in its current form after that reconnection, as the salt water that entered from the Mediterranean sank below the fresh water and began accumulating in the deep, cut off from the surface by the very density difference that its own presence created. The transition from lake to sea in the ecological and chemical sense was real. The bones of the old lake world are in the sediment record, and the bones of the new sea world are there above them. But the drama of the transition, the speed of it, the violence of it, the question of whether it was something that human beings experienced and survived and carried in their memory, that remains open, genuinely open. Not open in the way that some mysteries are left open for rhetorical effect, to preserve the sense of wonder at the cost of honesty, but open in the way that real science is often open, because the evidence is not yet clear enough, and the methods are not yet precise enough, and the models are not yet constrained enough to distinguish between the catastrophic version and the gradual version. Both are possible. The evidence, as it currently stands, is consistent with both. And the scientists who work on this question know that they do not yet have the answer. That uncertainty is the honest place to leave the flood. Not as a confirmed biblical catastrophe which the evidence does not support. Not as a disproved myth which the evidence also does not support, but as a real event in the geological history of this basin, the nature and pace and human significance of which is still being argued over by researchers at institutions around the world in a debate that has been running for more than a quarter of a century and shows no sign of arriving at a consensus soon. And the Black Sea, for its part, holds the evidence of its own past in the sediment on its floor, in the chemical signatures dissolved in its water, in the drowned topography of its margins. All of it waiting, not impatiently, for the tools and the methods to become precise enough to read the record clearly. It is patient in the way that very old things are patient. It has been here far longer than the debate about it. There is one more thing the sea is doing, and it is the thing that unsettles the scientists who study it most persistently, not the question of the ancient flood, and not the mystery of the wrecks, and not the sheer biological strangeness of a body of water that is mostly dead, but a slower, quieter change that is happening now, that is measurable, that is documented in the records of the past several decades, and that points in a direction that gives the researchers who track it genuine cause for concern. The boundary between the living sea and the dead sea, the oxic-anoxic boundary, the line below which the oxygen disappears and the hydrogen sulfide begins, the line that separates the world of fish and plankton and everything that breathes from the world of bacteria and sulfide and permanent dark, that boundary is not fixed. It has never been fixed in the sense that it shifts seasonally and regionally across the basin, deeper in some places and shallower in others, responding to the circulation of the surface water and the input of the rivers and a dozen other factors. But what the long-term records show is a trend, a direction, and the direction is upward. Over the past several decades, the oxic-anoxic boundary has been shoaling, moving toward the surface in parts of the Black Sea. The dead zone, the vast sulfidic deep that has always sat below the thin, inhabited skin of the sea, has been expanding upward, climbing toward the light, encroaching on the habitable layer. The boundary that was once reliably below 200 meters has, in some regions of the basin, risen to within 100 meters or less of the surface. The oxygenated zone where the fish live, and where the plankton bloom and where the sea does everything that a sea is supposed to do, has been getting thinner. The reasons for this are understood, at least in broad outline. The rivers that drain into the Black Sea carry not only fresh water but nutrients, nitrogen and phosphorus from agriculture, from fertilizers applied to the farmland of the enormous catchment that drains a third of continental Europe. When those nutrients reach the sea, they fertilize the surface water, fueling blooms of phytoplankton, tiny photosynthetic organisms that multiply explosively when the conditions are right. And when those phytoplankton die, their bodies sink, and the bacteria that decompose them in the water below consume oxygen to do so. More nutrients means more phytoplankton, means more decomposition, means more oxygen consumed in the layer below the surface. And the Black Sea, with its suppressed vertical mixing, cannot replenish that oxygen from below. There is no below to draw from, there is only the sulfidic deep, and cannot replenish it efficiently from above because the halocline limits the downward penetration of oxygenated surface water. The oxygen that gets consumed in the middle layers is oxygen that does not return quickly, and so the boundary rises. Slowly by the standards of human attention, not something you would notice in a year or even a decade if you were simply watching the sea from the shore. But measurable, when you have the instruments and the patience to take systematic measurements over time, and when you assemble those measurements into a record long enough to show a trend. This is not a local or isolated process. It is connected to larger changes in the watershed, in the agricultural practices of the countries whose rivers flow into the basin, in the climate of the region, which affects both the temperature of the water and the patterns of river flow and seasonal mixing. The Black Sea is, in this sense, an extraordinarily sensitive recorder of what happens on the land around it and in the atmosphere above it, because it cannot mix, because its deep water cannot be refreshed, because the balance between its living surface and its dead interior is maintained by a halocline that any change in salinity or river input can disturb. It responds to pressures that an open ocean would absorb without significant structural change. Scientists who study the basin describe it as a kind of canary, a living indicator, sensitive in ways that more thoroughly mixed bodies of water are not, of the pressures that human activity and climate change are placing on aquatic systems. When the oxic zone thins, the fish that depend on it are compressed into a narrower layer. The fisheries that have sustained communities around the Black Sea for thousands of years, and the sea has been fished for a very long time, as the wrecks of the ancient trading ships on its floor attest, are affected. The ecosystem changes in ways that are not fully predicted or understood because the Black Sea ecosystem, with its unusual chemistry and its unusual biology, does not behave like any other sea in the world and cannot simply be modeled on the basis of what happens elsewhere. And there is a longer shadow here, one that the scientists who study this basin think about in the context of the deep geological past. The word euxinic, used in oceanography and geology to describe conditions of deep water anoxia and high hydrogen sulfide concentrations, is derived from the classical Greek name for the Black Sea, Pontos Euxenos, the hospitable sea. The Black Sea, the world's largest euxinic basin, gave its name to a set of ocean conditions that have occurred not just here, but globally at intervals across the history of the Earth, when the deep ocean as a whole became anoxic and sulfidic, events known as ocean-anoxic events, moments in geological time when the chemistry of the deep sea went euxinic on a planetary scale, with consequences for marine life that were profound and in some cases catastrophic. The most recent of these ocean-anoxic events occurred in the Cretaceous period, roughly 90 million years ago. Earlier ones occurred at the Permian-Triassic boundary, around 250 million years ago, in the context of the largest mass extinction in the history of animal life on Earth, when perhaps 90% of marine species disappeared, an event so severe that it is sometimes called simply the Great Dying. The precise role of ocean anoxia and hydrogen sulfide in that extinction is still debated, but the chemical signatures in the rock record are unmistakable, and they look, in miniature and in reverse, like what the Black Sea looks like today. The Black Sea is not a precursor of some imminent global catastrophe. That would be an overclaim, and an irresponsible one. But it is a natural laboratory, the largest and most persistently anoxic body of water on the planet, a place where the conditions that once characterized the deep ocean during its most extreme and deadly episodes can be studied directly, with instruments lowered on cables into living water in real time, rather than inferred from the chemical signatures in rocks that formed hundreds of millions of years ago. The processes that operate in the Black Sea, the stratification, the sulfide production, the microbial ecology of the anoxic deep, the way the boundary between oxygenated and anoxic water responds to changes in nutrient loading and temperature, are the same processes operating at a smaller scale that shaped the chemistry of ancient oceans during those catastrophic events. Understanding the Black Sea is, in this sense, a way of understanding some of the most consequential moments in the history of life on Earth. That is not a small thing. It is, in fact, a remarkable thing. That a sea which most people know only as a geographical feature, a body of water on the eastern edge of Europe, bounded by Turkey and Bulgaria and Romania and Ukraine and Russia and Georgia, a sea that appears on maps as simply blue and featureless, is in fact a window into something much older and stranger and more significant than its appearance suggests. That the darkness below its surface, the sulfide and the anoxia and the permanent dead zone, the thing that makes it seem threatening or strange or wrong, is precisely what makes it scientifically invaluable. That what looks like absence, no oxygen, no fish, no aerobic life, is in fact presence, a presence of chemistry and microbiology and preserved history and geological memory that exists nowhere else on Earth in quite this form or at quite this scale. The Greek sailors who crossed the Black Sea in their wooden-hulled merchant ships, navigating by stars and coastlines, trading wine and oil and grain across the dark water, did not know that the sea below them was divided into two worlds that did not speak to each other. They did not know that a few hundred meters beneath their keels the water was thick with a gas that would kill them in moments if they could breathe it. They did not know that the ships of their ancestors, and ships far older than any their civilization could remember, were lying on the floor of that deep, in darkness, so complete and cold, so stable in chemistry, so hostile to decay, that the ropes were still coiled and the masts were still standing, waiting. They called it the hospitable sea. And perhaps in their experience of it, the trading routes, the fishing grounds, the harbors, and the cities on its shores, it was. The hospitality was real. The sea fed them and carried their goods and connected their world. The strangeness was simply deeper than they could see. What the scientists have done over the past century, and especially the past few decades, with the cores and the ROVs and the chemical samplers and the sediment records and the radiocarbon dating, is extend human sight down into that depth. And what they have seen there has not resolved the strangeness but has made it more precisely strange. They know now what the dead zone contains, and why, and roughly how old its current state is, and what the wrecks on its floor look like, and how well they are preserved, and what they can tell us about the people who built them and sailed them and lost them. They know that the boundary between the living sea and the dead sea is not fixed, and that it is moving, and that the direction it is moving in is one that demands attention. They know that the question of the flood, the great transition from lake to sea, is real and important, and not yet answered to anyone's complete satisfaction. And the sea continues in its slow and layered way to withhold as much as it yields. The sediment accumulates on the floor year by year, covering the old layers with new ones, encoding the present in the same way it encoded the past, adding to the record that some future instrument or some future method will read more clearly than any instrument or method available today. The deep water circulates so slowly that a parcel of water entering the bottom of the basin may not return to the surface for 1,000 years or more, longer, in some estimates, than the entire written history of the countries on its shores. The sulfide and the methane and the bacteria persist in their lightless chemistry, unchanged by anything that happens at the surface. The wrecks rest. The cores, once taken, are stored in refrigerated archives and reanalyzed as new techniques become available. The scientists who study the Black Sea return to it. They go back with new instruments, new questions, new collaborators, new funding that lets them deploy better ROVs or drill deeper cores or run more sensitive chemical analyses. They are not afraid of the sea, and they are not baffled by it in the theatrical sense of the word. But they are genuinely uncertain about it in the most interesting sense, the sense in which uncertainty is not a failure of knowledge but an accurate description of the current state of a complex question. They know more than they did 20 years ago, and far more than was known 50 years ago. And they know that there is more to know, that the sea is still ahead of them, that the questions it poses are not the kind that yield to a single expedition or a single paper or a single decade of research. That is what makes a sea worth studying. And that is what makes a sea worth lying still in the dark and thinking about as the night settles in around you and the questions become gentler and the need for answers becomes less urgent. And the strangeness of the world, and not just of a sea that is mostly dead, of a ship preserved for 24 centuries in poison water, of a flood that may or may not have been remembered across 7 millennia of human storytelling, becomes not alarming, but simply vast. The two-layer sea rests tonight as it always does, as it has for thousands of years. At the surface, the familiar dark water moves under the influence of whatever wind is crossing it, and somewhere in the upper 100 meters or so, the last traces of the light that fell on the sea during the day fade into blue and then into nothing. Below the halocline, the dense salt water that came from the Mediterranean sits quiet and cold, unmoved by anything happening above it. And below that, in the enormous volume of the deep basin, the chemistry proceeds without interruption, without oxygen, without light, in the slow bacterial dark that has been its condition for all of recorded human history and long before. The Greek ship is there, the mast is there, the rope, wherever it has rested across the centuries, is there. They are not going anywhere. They have all the time that the sea has, which is more time than anyone alive can comfortably imagine. If you are still with us, if the layers of this story, the halocline and the sulfide and the wrecks and the flood and the rising boundary have carried you this far without carrying you to sleep, then perhaps take a moment to tell us where in the world you are listening from tonight. It is one of the things that make these slow journeys feel less solitary, to know that somewhere in the dark, someone else is lying still and listening, letting an old and quiet sea fill the silence before sleep. The comments are there, and we read them, and we would genuinely like to know there are more stories here of the same slow and careful kind, stories of old places and deep waters and questions the evidence has not yet resolved. They will be here whenever you want them. For now, though. For now, the sea is quiet. The boundary between the living water and the dead water is somewhere in the dark below a surface that no one is crossing tonight. The ancient ships rest at 2,000 meters in water that nothing can breathe, in cold so stable it hardly changes by a degree across the decades. The rivers are moving in the dark, carrying the continent's water toward the same shore they have always reached, and the scientists who study this sea are, most of them, asleep. You have done enough for one night. Let the layers settle. Let the deep water be still and far away, and someone else's question to carry at least until morning. Like the old Stoics, let the day go. Tomorrow can be tomorrow's.